Hello and welcome to the Last Week in AI podcast, where you can hear us chat about what's going on with AI. As usual, in this episode, we will summarize and discuss some of last week's most interesting AI news. You can also check out our Last Week in AI newsletter at lastweekin.ai for articles we did not cover in this episode. I am one of your hosts, Andrei Kurenkov. I finished my PhD focused on AI last year, and I now work at a generative AI startup.
And I'm your other host, Jeremy Harris. I'm coming at you from Washington, D.C., actually from a place of a really, really good friend of mine. Excited to dive into this. I'm the co-founder of Gladstone AI, obviously, which is this AI national security company, which kind of been in the news a little bit. So I guess we'll talk about that. But yeah, big week.
We might. And yeah, Jeremy was out last episode because of some exciting DC-related adventures. So welcome back, Jeremy. Nice to have you back. And I'm sure listeners are excited.
Hey, and listeners should know, like, Andre's being a trooper right now. His body is 20% metal by mass, I believe. So he had wrist surgery yesterday, and he's coming off the meds, being a champ. So here he is. So anyway, big virtual high five to Andre on this. Thanks.
Yeah, let's hope this one comes out normal. Maybe I'm still medicated, but I think we'll see. We'll see.
Yeah, we'll have some fun with it.
And starting off with our first section, tools and apps. Not too many stories in this one this week. The first one is Adobe Substance 3D's AI features can turn text into backgrounds and textures. So Adobe has been adding various AI features throughout its product suite for a while now, and now they're adding it to 3D workflows with its Substance 3D design software. They have this new feature, text to texture, which will generate stylized or photorealistic textures from text descriptions, and that can be applied directly to 3D models, removing the need for you to make them. They also have a new second feature called Generative Background, which allows designers to use text prompt to generate background images for objects they're composing into 3D scenes. Similar to what they already have been releasing with their Firefly AI model, with generative fill and text to image, now in some 3D. And I'm sure, it's just a matter of time until they will go ahead and generate full 3D models for you, although that is not part of this.
Yeah, exactly. It seems like what they're actually doing is kind of putting together 2D images from those text descriptions and then rigging them so that they appear to render in 3D, which is kind of cool. We're in that intermediate phase now where, we've obviously covered text to image to blazes. Now we're doing text to 3D. This is one of the janky sort of hacky ways to achieve that. But I think it just goes to show you, often when it comes to generative AI, the products that work are not necessarily, they don't necessarily work the way that you think they might. And you can often get a lot of reach out of simpler tools. Another thing to note, one of the things about this is we're seeing not just full rendering of an entire thing, but rather fine tuning objects, generated artifacts in more sort of careful ways. So that, the generation is intersecting with editing a little bit more, and that seems to be a natural part of the way that this tech is maturing. So, kind of interesting to see that rabbit hole get deeper in ways that I wouldn't have expected would be the focus at this point. But I guess, Andre, in your game development, this obviously has applications for game design. Is this something that that you see as useful for your work today? Is this something that you could actually apply?
I mean, I'm sure game studios, there was another report by Unity of how game studios are already using AI in their workflows, and I'm sure people are starting to look into using things like the sort of generative texture stuff. So yeah, when you have to create 3D assets, there's a lot of possibility to integrate this sort of stuff there. And just one last note that I think is kind of interesting. They do also note in this story that these features were trained on Adobe-owned assets, including reference materials produced by the company and licensed Adobe stock stuff. So once again, they're pushing in this direction of, these are not going to be a copyright issue if you use it, as opposed to maybe some other models out there that are in more questionable territory for now.
Yeah, I think, wasn't Adobe Firefly one of the very first to play that game, right? They were saying, look, we're just going to train on data that we sourced ourselves, not going to do this big web scraping game plan just so that we can guarantee that you own the IP. Yeah.
Yep. And next story, OpenAI's chatbot store is filling up with spam. So this is an overview on sort of a state of the GPT store, highlighting some of the kinds of stuff that's popping up on there. The GPT store, for those who don't know, is OpenAI's version where you can basically customize a ChatGPT bot to do various things. It's a pretty straightforward process. You essentially just enter some text and say, okay, given a query, respond like this. And there are thousands, maybe tens of thousands, a lot of these customized chatbots that are already on there. And as per this report, a lot of them are, I don't know if I would call it spam, but a lot of them are maybe not what OpenAI would want to be on there. So there's a lot of them that are potentially copyright infringing. So they, for instance, are related to Star Wars, Disney, Marvel, stuff like that. And then there are also ones that are specifically for things like cheating. They promote academic dishonesty and claim that they can bypass AI content detectors used for plagiarism scanning for people doing their homeworks. So I suppose not surprising that given this like open platform from OpenAI, a lot of what's been put up is things that are maybe not what ChatGPT is meant to be used for.
Yeah, I think there are a couple of interesting notes about this. And first off, this is the classic thing that you run into when a company sees huge success and is forced to scale its operations really quickly. Of course, you're going to see a lot of things fall through the cracks. And of course, that gets expressed at the level of content moderation. That's one of the first places you'll tend to see that stuff. They do flag that they have automated systems to review this kind of thing. And frankly, I would have thought that automated systems could be developed to check for copyrighted material fairly straightforwardly. So it is surprising, even though we're seeing this kind of like growing pains from OpenAI here, it is surprising that some of these things are sneaking their way through. In addition to this whole challenge of like trademarks and copyright infringement, there's also this challenge that OpenAI is finding a lot of GPTs that are impersonating people or organizations without their consent or without legal right, which is, again, against the terms that OpenAI has on the use of the GPT store. So there are a lot of ways in which we're seeing people find cracks in the armor here and exploiting them. But ultimately, I think one of the things OpenAI is going to have to figure out, this does feel like another special case of the AI attribution of responsibility problem, right? Like on one level, you can put out systems that make it really easy for individuals to train their own AIs and then publish them on GPT store. On the other, though, whose fault is it if somebody comes out and violates those terms and then publishes it to your platform? We're kind of seeing the same dynamic play out as did with social media. But in this case, the implications seem a little more significant because other people, third parties, can now grab your copyright infringing GPT and deploy it even further, right? So we have a bit of an amplification here. So it'll be really interesting to see even the legal kind of the arguments for and against this possibility, because you're amplifying to some degree copyright and trademark infringement through this, and OpenAI will definitely have to figure this out. But the courts will have to figure it out. The whole system will have to figure it out. Welcome to 2024, I guess.
That's right. Just to include some specific examples in this article, they highlight a few. For instance, there's a chatbot called Monsters Inc. that is meant to generate monsters in the style of that movie from Pixar. So, you're not supposed to be able to generate images of known characters, but this is an example where it's specifically designed to do that. There's also various characters that you can chat to. So there's like Aang from the popular Avatar series. And one thing that's quite interesting, there's even some chatbots that are specifically said to be jailbroken. So there's like jailbroken GPT/Dan, which apparently means do anything now. And yeah, they are claiming at least that they are including some jailbreaks that make it so you can get around the usual things that ChatGPT would not do, like use, mean language, for instance. So yeah, it's a bit surprising that so many of these are still up, especially with jailbroken ones. But at the same time, as you said, I think it's still not super clear if OpenAI would get into trouble, for instance, for something where you have like an Aang chatbot. That seems probably less of a big deal. And as to whether the store is filled up with spam, I guess that's harder to say. It's not surprising that there is a lot of these kind of examples on there, but the story also doesn't make any real claims as to like what percentage of the chatbots are one type or another.
Yeah, and always the challenge, right? When you lower the barrier to entry for any platform to the point that they have here, you're going to get things that start to look and feel like spam. And one of the things that they're doing that is really enabling this is you don't need to know how to code to create one of these GPTs, right? You can literally just give it a custom prompt and then that's your own GPT. So, given that that's the case, people are basically coding these things or giving them instructions in plain English. Bar is awfully low, and no wonder we see some spam. And moving on to our lightning round, we have Apple's AI ambitions could include Google or OpenAI. This is a really interesting little note. So Apple, we know, is kind of trying to catch up a little bit in the AI game. They are apparently in active negotiations with Google to bring Gemini to the iPhone. And one of the interesting things about this, so, Apple's obviously been working a lot on AI stuff. Bloomberg is reporting that a bunch of AI features that are going to be built into Apple's products are eventually potentially going to be a mix of Apple's own AI and third-party AI models. One of the things that's interesting about this is, like, yes, of course, Apple wants its users to be able to benefit from state-of-the-art models, but it does sort of start to look a little bit potentially like an admission from Apple that their own generative AI tech is lagging. Because if you're Google and you're delivering the Pixel or you're delivering, some other phone that you yourself are building, you are building into a Gemini. You're not building, Chat GPT necessarily, putting that front and center. This is maybe an indication that Apple is kind of being forced to play some catch up here, trying to integrate their AI models as much as they can and make them load bearing, but sort of a recognition that actually, at least for now, we still need those training wheels. We still need those third party AI models.
And I just realized I was using the wrong mic, so you might notice a change in audio quality, hopefully for the better. But let's just keep on moving on. So yeah, this story does say that apparently there is an in-house chatbot called Apple GPT, and apparently the company Apple also has its own large language model codenamed Ajax, but they are inferior to the ones from Google. And I could see it. Certainly, I think one of the major difficulties that Apple would have is basically just compute infrastructure. You need really sophisticated capabilities to just scale up to the needed sizes to train the models, and then you need to also source the data. It's a pretty substantial project. So while they definitely, unsurprisingly, could train a large language model, it's also maybe not surprising that they can't quite match the level of Gemini or OpenAI, at least at their current state. And moving on to applications and business with the first story, of course, once again being about NVIDIA and the Blackwell B200 GPU, which is the new world's most powerful chip for AI. So there was a big conference in San Jose this last week where there was like a 2-hour keynote by the CEO of NVIDIA. And the big news was the announcement of this Blackwell B200 GPU, which is crazy. It's, a crazy jump in compute. They say it will offer up to 20 petaflops of floating point 4 horsepower from its 208 billion transistors. And it will supposedly reduce the cost and energy consumption by up to 25 times over the previous H100 chips. And they will cost something similar, actually, between $30,000 and $40,000. It's a pretty big leap in terms of the GPU. They actually showed the chip on stage, and it's basically just much bigger, is my impression. Some of the other numbers here is apparently this one has 7 times the performance of an H100 on a GPT-3 LLM benchmark. So yeah, certainly an impressive leap in capabilities over H100, which has been the workhorse for the last year or two.
Yeah, there's so much that's interesting about this particular chip. You mentioned the size, and part of the reason for that is that this is the first time that NVIDIA is not actually upgrading their node for a new generation of GPUs. So they're still going to be using this 4 nanometer, really 5 nanometer process to build this chip, which is the same that they used for the H100. So previously, what you would see is a new generation of node so now we can make semiconductors down to 5 nanometer or 3 nanometer precision, let's say, roughly speaking. And so every time you have a leap on that level of precision, you have a new generation of GPUs that NVIDIA puts out. Well, here we're actually not waiting for that next process to come online. We're just using the same node as the H100. One of the consequences of that is if NVIDIA wants to pack more compute on the chip, got to make the chip bigger, right? So they've essentially doubled the amount of silicon they're using here. They're using what's known as a 2-die design. So instead of having just one die, they've got 2. So this is a really interesting next step. It also, there are all kinds of questions about, the power consumption of this chip. And anytime you increase the power consumption, 2 things happen. And number one, you got to think about cooling. It looks like the B200 is probably going to be air cooled. Which is a bit of a surprise if you're tracking the space before. Water cooling is going to be the next kind of beat, where the power consumption is just so high that you can't cool these things with air alone. So you need a whole other kind of set of infrastructure, data center infrastructure, to cool things using water cooling. So there's a big porting expense there, but it looks like we'll still be able to use the air cooling for this. Another note too on the energy efficiency piece. That's actually really important. One of the big bottlenecks, in fact, it's emerging as arguably the bottleneck, at least in the United States, to setting up these big training runs, is the availability of energy to fuel the ridiculously energy intensive training requirements of these huge kind of data centers. And so having more energy efficient chips, very, very important. We're not bottlenecked so much by silicon, by hardware, by chips in the US. We're bottlenecked increasingly by energy. And so, different story in China, right? Different story there. They have tons of energy infrastructure. They're seeing more silicon bottlenecking, but at least here, it's a really, really important feature. And that's why it's become such a focus.
And just to be very clear, I may have kind of skipped over this detail. So they announced the B200 GPU and this GB200 super chip, which essentially combines 2 B200 GPUs onto a single CPU in there. So that's their super chip. And there were some other announcements that are of a similar variety, of more offerings. So they also are going to be offering this GB200 and the L72, which is kind of a big thing, but it's essentially a package deal of 36 CPUs and 72 GPUs into a single liquid cooled rack for a whole kind of mini, basically supercomputer. And it seems that all the cloud providers are going to be looking to buy these racks and allow them. So NVIDIA continuing to push forward on the ridiculous kind of frontiers of what their chips are capable of.
Yeah, and actually, so the GB200, you're absolutely right to flag that. It's being called the Oberon platform. That's kind of the code name they have for it. It's really important because the previous generation, so the GH200, was unfortunately didn't kind of take in the market the way that you might have hoped if you were NVIDIA. Part of the reason is that the CPUs that they were using, they integrated with, as Andre, you said, with the GPUs on this big kind of system. The CPUs just were not the kind of total cost of ownership doesn't work out really well. They're not terribly cost efficient. NVIDIA hasn't kind of cracked that code yet. So one of the things that's happening with the GB200, the new one, is they're halving the number of CPUs that are required. And so that basically halves at least the CPU part of the total cost of ownership. So it makes it viable. So that's why a lot of people are looking at this and saying, hey, you know what, maybe this kind of more integrated setup is now all of a sudden going to be a lot more appealing. So we may see this emerge as a new sort of a new standard for at least those really large scale training runs. This is what that infrastructure is supposed to power.
And on to the next story with another company we cover quite a lot. It's time to talk about Microsoft and this pretty interesting development with Inflection AI. So Microsoft has agreed to pay $650 million to Inflection AI to license its software and hiring the majority of the startup's company, including the co-founders. So Mustafa Suleyman, who was the co-founder of DeepMind and of Inflection, will now move to Microsoft and be head of its consumer AI business. Basically, people are saying that this is kind of like an acqui-hire, where you acquire a company to hire its staff, but without the acquisition part. They are paying this money to license the chatbot Pi that we've covered before. That is what Inflection was working on. They had their own custom chatbot that was pretty well received, but supposedly they couldn't find a way to commercialize. And they were kind of in talks to try and find more funding in recent months. And it seems that the outcome of all that has been in this pretty interesting, kind of unusual development of Microsoft paying out to hire the company's engineers and founders without just buying the company.
Yeah, and so really weird deal structure. By the way, in Silicon Valley, acqui-hire is almost like a bad word. It's sort of like the if you're a startup founder, it's good. It can be a good outcome for you, depending, but it isn't what you're there to do, right? You're there to get acquired for your customers, your income, your IP, the whole package. An acqui-hire is sort of like an unbundling of your company. You're kind of getting sold for parts. No shame in it, obviously. I mean, everybody's doing their best, but this does play into the thesis that we've talked about on the show before, that, at a certain point, there is a proliferation of all these companies that have raised solid but not incredible amounts of capital. And unfortunately, that just, in a world where scaling is key to get to AGI, there's no real prize for second place. And these companies, if you're not going to raise the tens of millions of dollars that you need to compete with OpenAI, to compete with Google DeepMind, with Anthropic, it's just really difficult to see how the math works out. And I think this is the latest example of that. You look at also other companies, even companies like Cohere that on paper seem to be raising decent amounts, but just they're not on that scale of OpenAI. I'm pretty skeptical of companies like that, unfortunately. And I think Inflection was we may have talked about it even at the time it launched. I'm pretty sure we did. This is the outcome that you kind of expect for that tier of companies. Not that they're not super talented, and hopefully, they prove me wrong, but this is kind of what we're seeing here. So that's one piece. Another, though, if you zoom out strategically, what is Microsoft doing here? They're looking at OpenAI with Sam Altman trying as hard as he can to break free of the stranglehold that Microsoft effectively had on OpenAI through their provision of compute and other resources. What's Sam Altman doing? $7 trillion AI chip scaling venture that he's trying to set up, another source of AI hardware, trying to go independent. What's Microsoft doing? Well, we're not going to be attached to the hip to OpenAI when it comes to our AI model training needs. We're going to acquire Inflection. So you can kind of see this as this delicate game of chess they're both trying to play as they circle the drain, trying to keep leverage over each other. And this really is just another big move on the giant game board that's shaping up right now between those two companies.
Right. Yeah. So supposedly of the 620 million went to just license Inflection's AI's models, and 30 million went to waiving any legal rights related to mass hiring, according to at least one person. But by licensing this Pi model, which by all accounts is a quite good chatbot that I think is pretty much trained from scratch. So they, or at least is quite customized to be a very good chatbot. They saw a lot of consumer uptake with up to 1 million users, but just couldn't turn that into a profitable business. So Microsoft is diversifying a little bit its stakes beyond OpenAI. We also saw it invest in Mistral, and now there's this development. The payout has actually made the investors in Inflection whole, although the return isn't great. Still, it's kind of a nice outcome overall for Inflection in terms
Call it
of
a soft landing.
Yeah, you could say it turned out pretty well. And after the lightning round, first up, we have Figure 01, Conversations and Actions in Humanoid Robotics. This is a little article highlighting a little demo by Figure and OpenAI. So we've covered before how Figure has made a deal with OpenAI to leverage their technology to have the intelligence for their humanoid robots, which is what Figure is using. And so they released a video where they showed that a human could talk to a Figure humanoid robot and tell it to do various things. So, for instance, there was an example of it being told to sort some laundry, and the robot was actually pretty impressively able to pick up various pieces of clothes, put it in a basket while talking to the human, similar to how something like ChatGPT would talk to you. So they released this demonstration of the integration of ChatGPT type intelligence with a humanoid robot, and it was, I think, a pretty impressive demo, at least. Although it's hard to say how kind of general the integration has been.
Yeah, it's sort of our classic advice when looking at demos, right? Like a demo is a demo; it can be an impressive demo, but ultimately, it's hard to know. It's also hard to know what exactly it means for ChatGPT to be integrated in this like robotic system. I did a little bit of digging to try to find some information there. I wasn't able to dig anything up, but I'd be curious if listeners have anything to point us to. One of the things that they highlight is that this is all being made possible, as they put it, by leveraging an advanced vision language model and integrated cameras. Okay, so that's pretty much what we've got. We have examples of systems like this, early versions like Saycan from back in 2021, I think, where essentially you take in a verbal instruction, it gets broken down into a series of clear robotic tasks, and those tasks get farmed out, potentially translated as well on the way into kind of robotic control code. But we don't know how deep the stack is. Like, is this basically one giant neural network, or is it, it wouldn't all be that. It'd be some wraparound, obviously. But how neural network is this whole thing, and then how classical robotics is this whole thing. Figuring out where that interface lies, I'm always super curious. But this does make me think of, I think last week or 2 weeks ago, we talked about Sanctuary AI and their like freakishly natural looking robot that was doing something similar. This really struck me in the same way, right? It had very natural looking, kind of seamless movement. So interesting to see both those things coming around at the same time, especially given that they don't use the same hardware. Right? I think Sanctuary was using hydraulics. Here, they're using the sort of standard, electrical arrangement. I'm not a robotics guy, so there my ignorance is definitely showing. But I thought it was really interesting and impressive, and I just wish there was more information on the actual architecture.
That's right. Yeah, we really don't know too much. We just have these videos coming out of Figure, but it does kind of serve to continue to put Figure as a front runner in the race for general purpose humanoid robotics. I think it's fair to say that their tech is pretty impressive, and they're seemingly leading the curve in terms of their technology.
Next up, we have a leak. We always love the leaks here on Last Week in AI. OpenAI's GPT 4.5 Turbo leaked on search engines and could launch in June. I thought this was really kind of interesting, and I'm personally still trying to fit all the pieces together. So Bing and DuckDuckGo apparently indexed the GPT 4.5 Turbo product page before obviously an official announcement could go out. The index link for that model currently leads to a 404 error page. But you can see teaser text and there's a screenshot in this article, but you can see some teaser text in the search engine that says, GPT 4.5 Turbo is OpenAI's fastest, most accurate, and most scalable model to date. So, all kind of tracks. Apparently, if this leak is true, at least it would have a 256,000 token context window, which I think is interesting because, you think about Gemini 1.5, there we're already at a 1 million token context window. So, it's interesting that if this is the next beat for OpenAI, GPT 4.5, it doesn't rise to the context window size of the full Gemini 1.5, which admittedly is not released in full form, but then we're still talking about a June release ostensibly for this. So, I might have expected maybe just a larger context window, but maybe it'll be, superior in performance in other ways. But some folks are thinking, maybe this is all a strategic bit of like marketing, and really what they're trying to do is take the wind out of Anthropic sails. Anthropic, of course, just announced Claude 3, so they're getting all this press, and now here goes OpenAI sort of conveniently leaking information about a potential leak of GPT 4.5, which is obviously super, super hotly anticipated. So really, really hard to know what any of this is, if it's real, but kind of an interesting bit of insider gossip.
Yeah, it's fun gossip for sure. And it does seem, fairly plausible that the next release would be GPT 4.5. It did have GPT 3.5 before GPT-4, and it would be a pretty natural extension of the capabilities. We've seen them kind of continually pushing forward step by step. So yeah, we don't know, but now we have this fun bit of potential leak info, and we'll just have to wait and see if it is true. And continuing the topic of OpenAI, the next story is that Abu Dhabi is in talks to invest in the OpenAI chip venture. That's kind of most of what there is to the story. This is about state-funded MGX being in discussions with OpenAI regarding this very ambitious venture that we've been covering for a little while now, where it could go supposedly up to $7 trillion over the next several years. Would not be too surprising to see Abu Dhabi taking a part in that. They are also, dedicating a lot of money. I think they have a 40 billion fund separate from this to invest in various AI efforts. So yeah, that is pretty much all there is to the story. It does seem like, there's some movement happening in the investment front of this effort. So it could actually amount to something, but it's still early days.
Yeah, absolutely. And Abu Dhabi is such an interesting, or I should say the UAE is such an interesting player in this space. So the fund itself, MGX, it's this AI focused fund. It's chaired by the UAE's national security advisor, this guy called, and I'll butcher, I'm not even going to try. I will try it. Okay. The listeners want me to try it. I'll try it. It's Sheikh Tahnoon bin Zayed Al Nahyan. Hopefully I didn't butcher that. But anyway, so Sheikh Tahnoon, as his friends probably know him, is apparently the brother of the UAE president. And so he's overseeing like this gigantic, they say it's a $1.5 trillion sprawling empire that includes 2 sovereign wealth funds and private businesses. And he also chairs G42. And if you're a longtime listener of the show, you might recognize that as being a company that has a whole bunch of interesting AI efforts that we've covered before, trained really big models, and they have partnerships with OpenAI, Microsoft, and Cerebras. Again, we've covered those too. So UAE really becoming a focal point for AI, trying to make that their differentiator, and sort of proudly touting the fact that Sam A said that they were into AI, before it was cool, like back in 2017. One of the key things to recognize, Sam Altman, like you said, Andre, who knows, but trying to raise the $7 trillion fund, this would price out like basically everybody except for like gigantic sovereign funds. And so that's really why you're seeing this kind of engagement with the UAE, which is a really interesting partner from a national security standpoint, because they stand sort of between China, between Beijing and Washington. They're trying to dance this delicate dance. There's been a lot of skepticism about the relationship between, for example, G42 and Chinese companies like Huawei, which are on Washington's export blacklist. So like there's a lot going on. The UAE is taking a strategic decision to try to prioritize US tech partners, leaning into that and cutting off a lot of its Chinese partners so that it can play in this little sandbox. But they've got a lot of these entanglements to resolve, and we'll see where it goes.
Next up, going back to NVIDIA with our last story for the section. NVIDIA announces GR00T, or I guess you're not supposed to say it, but Groot.
It's not Groot. It's not Groot.
It's a foundation model for humanoid robots. So this was another one of the major announcements that came out of that presentation. Groot, or GROT, stands for Generalist Robot 00 Technology. They, in the presentation, made sure to spell it out, not to say that acronym, because I guess they don't want to get in trouble with Disney. But the gist is this is a new major initiative for them to train a foundation model, a really large model trained on tons of data for robotics, broadly speaking. There's not a ton of details yet. Basically, they're saying that this will be a model that enables humanoid robots to see and move and just, I guess broadly do whatever. It's being run by several NVIDIA researchers who have been around for a while. So just a new kind of initiative that they're kicking off.
Yeah, and there's a big push to set up this big open source robotics alliance that NVIDIA in this announcement is also committing to be the founding platinum member of. So at least what that means, hopefully, is that we'll be able to talk more intelligently about the architectures behind a lot of these robotic models in the future. This is something that I find keeps coming up, and for some reason, the culture of robotics seems to maybe be less open source, at least in the commercial product side than maybe some others. So kind of interesting, and we'll see if it actually takes.
And on to projects in open source, with the first story being the open sourcing of Grok 1. And that was probably the big open source story of the last week. So xAI, Elon Musk's big OpenAI competitor, tweeted last week that they were going to open source Grok 1, their large language model, and they did on Pi Day 314. So they released the full set of weights. It's a 314 billion parameter mixture of experts model trained from scratch by xAI. And they were released the weights and architecture of Grok 1 under the Apache 2.0 license. So you could basically do whatever you want with it. So the biggest, by far, open source model we've seen released so far. Reactions to it seem to be that it is, not super impressive. At least it's potentially undertrained. So if you compare it to smaller open source models like Mixtral, it seems to be about on par, maybe slightly better, but kind of punching below its weight in some sense. But still a lot of excitement in the community over the release, and now various corporations might take this and train it some more to make it even better.
Yeah, and it kind of shows you just how far Elon's willing to go to kind of do trolly little dad jokes. The model you said had 314 billion parameters. It was released on Pi Day 3.14. Ha ha ha. I think that's like legit. Like that is probably the reason. But the architecture kind of interesting. So we've talked about mixture of experts models before, of course, but just as a quick primer, like you have a layer to this, or a component to this model called the switch. That sort of takes in an input token, and then it's going to route that switch to different experts, like submodels, basically within the overall architecture. And this model has 8 of those experts, and in each forward pass, the router will send the input token or the input data to 2 of those 8 models. So only 2 out of 8 of those experts, or about 25% of the model weights, are actually active on any given forward pass. So other things we know about this model, it has an 8,000 token context window. So, that's a decent size, kind of useful for a lot of things, especially as open source models go. It does support a couple things that are interesting. First is 8-bit quantization. So this allows you to take the model and basically compress it down, right? So that instead of representing all the numbers in the model with kind of a whole gigantic ton of floating, of digits after the decimal, their values, you're compressing that representation down to 8 bits. So it makes it a lot more portable. It makes the model a lot smaller. The other thing it supports is activation sharding, which is a technique that you use to improve the efficiency of like model training and inference by partitioning basically the activations of the model across a bunch of different devices. So basically just things that allow you to make the model smaller so that you can deploy it on more devices and make it easier to train further or deploy. So kind of interesting. We also know that this is an uncensored model, of course, because it is Grok. So you can ask it how to break into a car and it will tell you. So it's an interesting next step in the evolution of the truly open source uncensored model space. This is like Bad Llama. This is like a lot of the other uncensored models that we've seen. It does establish a precedent. We'll see if Grok, or I should say if xAI keeps doing this going forward. If so, that keeps, like so many other open source models, it keeps raising the bar for the private development of these models. For companies that don't open source, OpenAI has to keep pushing further and further if they want to keep their margins high, so that there is a clear kind of performance gap between their models and the open source. So just more pressure on the frontier labs, I guess, and interesting to see if Elon does keep. Obviously, he's open sourcing. This is partly a taunt, right? The idea behind this is to taunt OpenAI because he has been critical of them. The whole joke of like, hey, you should call it closed AI, blah, 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 and all that. So this is very deliberately targeted in that direction. And I don't know that it will actually have that impact because, as you said, Andre, the model itself it's not exactly a blockbuster in terms of performance, but still.
Yeah, but still, it certainly is big, and we've seen this happen over and over. Where, for instance, with Llama coming out, we then saw many like offspring of Llama, of people taking it,
Yes,
and training some more, tweaking it, and getting it better and better. We saw this with Yi as well, another open source model. So I would not be surprised to start seeing variants of Grok that are much better. And just one more fun tidbit. So, of course, there's also Elon Musk is a big proponent of his uncensored AI, not having any limits. So on top of having an Apache 2.0 license, the code of conduct for the model is literally just be excellent to each other. That's all it says.
Done. I fixed
GitHub.
It for you.
Yeah. So much less detailed than a lot of the other code of conducts of, let's say, like Llama, for instance, is pretty detailed. Like, you're not supposed to use it for bad things. Here, be excellent to each other is all there is to it. Next up, Stability AI brings a new dimension to video with Stable Video 3D. This is about the paper SVD3, novel multi-view synthesis and 3D generation from a single image using latent video diffusion. So in short, Stable Video 3D, as the name implies, based on some text, you are now able to render what is kind of like a 3D video. So there's a panning shot of some stuff happening, so you can like rotate around a character, for instance. And this is coming a couple months after something like Stable 0, 1, 2, 3 that generate 3D models. This is different in that they are actually using an image to video diffusion model along with camera path conditioning. So that results in this multi-view video of an object. And as with some of their other recently released models, you are able to use it commercially with the Stability AI Professional membership, which is $20 per month for creators and developers. And for non-commercial purposes, you can go ahead and actually download the model weights from Hugging Face. So similar in some ways to other functionalities you've seen from Pika, for instance, to be able to do this kind of panning view of a scene. Cool to see Stability continuing to release models at a pretty high rate still.
Especially given some of the drama that's been going on there lately. I think we'll probably cover that in a next week's episode. But like, I noticed just before we started to record, Emad Mostak was resigned from Stability. So anyway, we'll cover that for sure. I think this will be an interesting entry as well in the whole world model debate surrounding generative AI, generative video models. We saw with Sora, this question came up of like, if you've got a model, in that case, they could make a video, a 2D video, but that reflected certain physical processes. They could capture the shattering of a glass, let's say. Then does that mean that it's deeply understood in some sense? Something like some laws of physics to some level of granularity. The more you see this sort of thing happen, the more that question is going to be raised. So I don't think that this is necessarily kind of at that level where it caused us to navel gaze and think about that sort of thing. But it's definitely on the way, and these techniques can add up to give a model a more robust, internal world model, internal representation of what's going on. So yeah, great work, stability, and we'll talk about Emad Mostak next week, I guess.
Yeah, there's been some drama going on, also some major researchers leaving. So I guess we'll bundle all that up to discuss later. And just a couple more stories in the lightning round, starting up with Colossal AI team introduces OpenSora, an open source library for video generation. There you go. That's the gist of it. Of course, Sora is from OpenAI and kind of blew everyone's mind. Here, OpenSora is a replication of the architecture from the Sora model, which also reduces the training cost by quite a bit and also extends the length of the model training input sequence to a larger number of patches. Not quite as impressive as Sora, of course, in terms of the example outputs, but it is an open source variant that others can build upon to create, I guess, something akin to Sora. And just one last detail. So this is OpenSora 1.0 that they released, and it can produce 2 seconds of 500 by 500 resolution videos with a couple days of training. So they have some example videos on the GitHub. They already look pretty decent, nothing quite as close as Sora. And they have various to-dos for upcoming things and so on. So it's kicking off a new open source project. Next up, we have a new effort by Sakana.ai, which is a company from Tokyo, Japan, started by David Ha and some other folks. And it is about evolutionary optimization of model merging recipes. With the gist being that they have a new way to merge models in a kind of evolutionary approach, and they use that to create several new Japanese-specific LLMs. So they have a Japanese LLM with math reasoning capabilities. They also have a culturally aware Japanese visual language model. And they go ahead and release some of these Japanese-specific models for open use, which is why it's in this section. And besides contributing the models to the open source community, also, of course, have this new paradigm for model composition, paving a way for basically trying to combine different language models to achieve new capabilities.
And up next, we're on research and advancements, and we're opening with a Google paper, DPACO, Distributed Path Composition. And so, okay, this is an attempt to do a paradigm shift at the level of the hardware, the interaction between the hardware and the software used to train AI models. So right now, one of the big challenges is, you can imagine, in the world of training and inference for models, we have a ton of compute lying around in a ton of different places. Often when you train big models, you have to centralize that training and have a whole bunch of identical GPUs all working in unison and hooked up together with an architecture networking that assumes that all those GPUs are identical and all in basically the same place. And so the idea here is, like, can we change that paradigm? Can we have a more distributed world where you have some query that comes in that is routed to what they describe as a path, rather than like a whole model? They're inviting us to think of something kind of like almost like a mixture of experts situation, where you have a whole bunch of, start by thinking of them as experts. Maybe you have 8 different experts in one layer, but then there's like another layer of experts on top of those. And your query could get routed to, expert A in layer 1, and then expert C in layer 2, and so on. So essentially, you can think of your data as navigating a path, a journey through the layers of this network. And that path could depend on the data that you provide as an input. Now, by doing that, by essentially defining paths ahead of time, before training even begins, or before inference even begins, what you can start to do is allow people to locally have, just like you're responsible out in Moscow or something, you're responsible for training just one potential path that your data could follow. Somebody else in London is responsible for training a different one. So we can distribute, in that sense, the training of otherwise what would be a large monolithic architecture. And so essentially they break down the journey of data through a model like this. They design an architecture that has these paths deliberately built in. And depending on the nature of the data that's fed in, that data is clustered as belonging to like one path or another. So that at a high level is what's going on here. There's a lot of really interesting technical work on how to define these paths, how to sort inputs into these paths. But yeah, at a high level, this is the idea. It's meant to kind of distribute the training process to make it possible for people to, as they put it, compose these paths together, compose training that's been done at many different sites into one model that doesn't have to live on any one piece of hardware.
Right. It's an interesting research paper in the sense that it proposes a new direction. In the abstract, they say we consider this approach as a first prototype towards a new paradigm of large-scale learning, one that is less synchronous and more modular. So going away from having a single large neural net as you do today towards this more, kind of spread out approach. They have some demonstrations of it working. So they say that they are able to optimize and exceed the performance of a 1 billion parameter dense transformer language model by choosing one of 256 possible paths, each of those with a size of 150 million parameters. It's kind of interesting to me to think that Google was also, in addition to originating a transformer, in a way, they pushed in a direction of a mixture of experts quite early on.
Yes.
In 2017, they had the paper on, I think it was like outrageously large neural networks that doesn't get acknowledged quite as much as a transformers paper. But yeah, a very long time ago, they were thinking through this idea of outrageously large networks. So this, in a way, reminds me of that, of another way towards really scaling up to something ridiculous, which I suppose, if you're talking about like trillions of parameters, maybe we'd want to go towards this more decentralized approach as opposed to the current paradigms.
Absolutely. And I think, one of it's funny. So you mentioned mixture of experts, and that's exactly the right frame here. That is the philosophy. One of the challenges, so when you train a mixture of experts model, right, you feed in a token, and then the switch, the router at the beginning of the model that decides which expert is going to receive and process that data, it makes that decision in real time. And so you imagine like you kind of have to have the whole thing to some degree integrated together, because the decision about which expert is going to receive the data is dependent on that activity. And what's going on here is they have to so that they do what they call offline routing. Basically, the prompt that you give the system when you're deciding, okay, which expert which path rather is this going to be fed to, you make that decision out the gate. You make that decision based on the first, as they put it here, the first 32 tokens of text. And you basically do you embed them in a latent space, as I understand it, and cluster those tokens and see okay, do they look like, they use literally k-means clustering, which is like a dead simple clustering algorithm. And so they try to see, okay, those first 32 tokens, do they match, are they similar in topic to one of these clusters? And then whatever cluster they get matched to is associated with a specific path through the model. So it's a very almost like a coarse way of replicating what a router does in an offline manner. So it's, before you even feed the token to your model, you've already predefined which path, kind of by analogy, which expert, but which sequence of experts or which sequence of layers you're going to send it to. So it is, in that sense, a bit of a sacrifice, right? You're sacrificing the nuance of being able to munch on that data too much before you send it to a given path in exchange for the insane scalability of this. So you use a very naive routing mechanism, and then you have insane scalability. So I think that's a really interesting component to this. And I'm really curious if this does become the next evolution in all this. We may see, I don't know, maybe the distributed data center becomes a thing and we see less centralization. Obviously, Google's already done a lot of work in terms of patching together the inputs of many different data centers to train models like Gemini. So in a sense, this is philosophically aligned, but it is conceptually very new.
Next up, a paper from Apple called MM1 Methods, Analysis, and Insights from Multimodal LLM Pre-Training. So they released this paper with quite a few authors that essentially highlights lessons on how to build performant multimodal large language models. They study the importance of various architecture components and data choices and present this overall summary of kind of when you try out different image encoders, different combinations of data, vision language connectors, various pre-training choices, etc. Like a lot of these sort of, I guess, nitty-gritty details of how you do your training. They come away saying, these are our key insights as to how to train a good vision language model. And this, by the way, multimodal large language models, it's a model that can, for instance, caption text or classify what is in an image, that sort of thing. And they scale up quite a bit. So they build MM1, which is a family of multimodal models that goes up to 30 billion parameters in size. Also, some having a mixture of experts variants that are state of the art in the pre-training metrics and are also competitive. So they're able to basically scale up pre-training in a pretty good way and publish this paper that has their insights that are, I guess we could cover some of them. Like, for instance, image resolution has the highest impact, followed by model size and training data composition, according to them and their insights.
Yeah, I thought it was really interesting. And, we talk a lot about open source and what technically qualifies as open source models. That's always a debate, right? Elon just open sourced Grok 1. So what does that mean? Like, he open sourced the weights, he published the weights, but did he publish all the model checkpoints? Did he publish the code? And then you can ask, did he publish the experiments that led to the decisions about the architecture that ultimately were used? And this is an attempt to step all the way back to that point. I think it kind of makes sense. If you're Apple, you feel like you're falling behind in the race a little bit. What's the way that you can make a contribution that is undeniable, given that you're trying to figure it out yourself? And this is really, it seems like Apple trying to figure out, trying to replicate a lot of what we've seen with multimodal models, like Sora, like DALL-E, that sort of thing, and then publish it openly as they go. And you might as well get the marketing hit out of it. It is a really interesting piece of work. It does give us visibility into the micro decisions that go into this, as you said, Andre, which is something that we usually lack. And I actually found that really, really interesting. One of the things that they highlighted that I thought was really interesting, they were looking at, for few shot image captioning and text only tasks. One of the things that they found was it's really important to kind of interleave a mix of image captioning data and also text only data during training. So, that's not an obvious thing. Like, at least in the old paradigm, you would just train a thing to do text autocomplete and nothing but text autocomplete, right? That's how GPT-3 was trained, for example. And to some degree, we think GPT-4, obviously there was instruction fine tuning there too. But here we see, this question of okay, how do you actually, what is the appropriate mix of training data, but also in what order do you feed it? And it turns out that, actually staggering the order and doing some captioning, then some text-only data is actually important. Who knew? But of course, it does depend on the task that you're measuring. So if you just care about few-shot image captioning or text-only tasks, then that makes sense. Apparently for zero-shot image captioning, so if all your testing is with no prior examples given to the model in its context window, you just want to see how it does in image captioning, well, maybe no surprise, just image captioning data is the most important thing. So, it's somewhat intuitive, but still interesting to see these things validated. Interesting stuff about the data mixture. They ended up settling on a careful mix of 45% interleaved image text documents, 45% image text pair documents, and 10% text only documents. So that text only piece I thought was really interesting. I would have guessed would have been much bigger. So that was a big update for me. I would have thought, I don't know, you train this thing with 50% text only stuff, and then you do images for the rest. So really fascinating update, at least for me on that one. So this will stand, I think, as an important guidepost for anybody who's trying to train their own foundation models, because as far as I know, this is the most in-depth kind of description of a highly scaled quality run that did result in, at least for open source, a legit state-of-the-art model here.
To be super clear, I don't think they have released the weights. They might, but they do say in the paper, we hope that the identified lessons will help the community in building stronger models beyond any specific model architecture or data strategy. And I do agree. This is like super helpful stuff to publish with nitty-gritty decisions and insights that usually does not get published, especially in this day and age with papers on Gemini or GPT-4. We don't even know like the size of a model, much less all these nitty-gritty type details. So a really useful contribution from Apple. Next up, Pearl parameter efficient reinforcement learning from human feedback. So RLHF is, of course, often used to fine-tune chatbots to be better at aligning what humans want to do. And this is presenting a parameter-efficient version of that uses lower rank adaptation to train models more effectively. So they say that Pearl is basically as good as traditional RLHF, but trains faster and uses less memory, making it more accessible to align for released large language models. They also released 2 new datasets, Taskmaster Coffee and Taskmaster Ticketing, to be able to benchmark and research variants of RLHF.
Yeah, and this ends up looking a lot like many of the other LoRa like experiments that we've seen with LoRa recently, right? Where you radically reduce the amount of parameters that you actually have to train or fine tune to accomplish your fine tuning objective. In this case, they trained models to match the performance of fully fine tuned ones using less than 0.1% of the parameters that were being tuned. So you're talking about a huge savings of compute here, making it a lot easier and faster to train these things. They also find that this LoRa technique generally becomes better at matching the full fine-tuning performance as you increase the scale of the model. So as the LLM gets bigger, you actually find that you can benefit more from using this LoRa technique. Apparently, across all their data sets, they say that the reward models can be tuned with approximately 50% of the memory needed for full fine-tuning. So they save a ton on memory, and the training converges in a similar number of steps to full fine-tuning. So just advantages across the board here. LoRa continues to be a really, really powerful tool. I feel like it's one of those things where people discovered it, and we're still living in the kind of fallout from that, where people are finding more and more new use cases to just throw it at. So this is yet another one. Reinforcement learning falls to LoRa.
Next up, Video Agent, long-form video understanding with large language model as agent. So yet another paper on agents, where once again, the difference between an agent and a model is that an agent has sort of a continual action method. It takes iterative decisions to accomplish some sort of goal. In this case, the goal being video understanding. So it can answer questions about long videos via a sequence of steps where it can translate and retrieve visual information. So for instance, it can be given a video and be told to answer the question, what does the dog play with at the beginning? And then the agent would retrieve various frames from a video and answer it's playing with this toy because that's what has been seen.
Yeah, and this is an interesting paper because it starts with a claim about the way human beings actually process videos ourselves, and the idea that, well, actually, maybe we should mimic that process more than using maybe you could call them brute force approaches of current video understanding models. So they claim that humans start by doing this quick overview of the video to understand its context, and then that we iteratively select new frames to gather relevant information once we have that kind of broader context. And that might not sound like what we actually do when we watch a video, but when you think about it, it doesn't fit too badly. And I'll just map it onto what the model actually does, and hopefully it'll make a little bit more sense. You start off, you have your video, and this thing will sample frames at a high level, like might sample frames for 10% of frames or 1% of frames from the video. And it'll see okay, can I answer the questions being asked based on these frames, right? And if not, what frames should I be looking for? Like, is it likely that the answer is between, frame 17 and frame 18 that I have here? And if so, it'll sample from the frames between those frames and then see if it can, again, get the answer based on that. And so you have this iterative process of kind of like diving into in more and more granular detail the video at the frame level until it satisfies itself that it can actually answer the question. One of the things that this does, we've talked about this on the podcast before, but increasingly we are seeing a shift, it seems, towards more and more of the compute being used at inference time in the form of, agentization of problem solving, rather than just feeding a question directly to a big model and having it answer in one shot. So rather than investing all your time in the training stage, preparing these things to answer questions in just one step, we're investing more of our compute at inference and finding ways to kind of prompt the same model multiple times and having it iteratively reason through the problem solving process in some predetermined way that makes things work out better. So this particular model, the results are pretty good. It apparently compares favorably to GPT-4V, which of course is the kind of vision enhanced version of GPT-4. And they have verified that this whole process of iterative frame selection, where it kind of starts off with a broad picture of the video and then gradually zooms in to find where the answer is probably hiding, that is actually really important. They've done ablation studies to confirm that if you get rid of that, you get much worse results. So pretty impressive, and the agentization of everything. I mean, I think it's a trend that really seems to be universal across, whether it's language, logical problem solving tasks, or video or images. We're seeing it more and more. It's an interesting application of the video space for sure.
Last story in the research section: music hi-fi, fast, high fidelity stereo vocoding. So that's pretty much the story. This is a very optimized vocoding application that is able to have an AI filter on top of some voice. They have a cascade of free generative adversarial networks to convert low resolution spectrograms to audio and upsample it and so on. And they say that because they have a cascade of models and don't need to do a sort of iterative approach as you would usually with diffusion, this can be quite a bit faster. And they have some examples on the website where you can listen to it, and it's not necessarily obvious where the AI generation is, as opposed to often with these audio generation models, they've been a little more full of artifacts, whereas this one is pretty clean.
And up next, we have policy and safety, and we're opening this up with a benchmarking kind of model evaluation metric type of paper, which is actually really interesting. So it's called the WMDP benchmark, measuring and reducing malicious use with unlearning. So two things about this paper. They're actually doing two different things. The first is they're defining a benchmark for evaluating the capacity of AI models to do things that lend themselves to weapon of mass destruction type risk. So, chemical weapons design or development, bioweapon design development, and cyber attacks. So those are kind of the three main categories they're looking at here. The other thing that they're doing is they're trying to figure out, okay, using this benchmark, can we cause our models to forget the knowledge required to generate those threats, to generate those risks? So those are the two different things. This seems to have been spearheaded by some folks at the Center for AI Safety, among others, and they've done a lot of work on the eval side. But one of the really interesting things that comes up, so let's start with the benchmark piece, right? The evaluation piece. How do they do this? They started by getting together a bunch of experts. They say it cost them over $200,000 to do this, to develop over 4,000 multiple choice questions that measure, biosecurity, cyber, and chemical security knowledge. And one of the challenges when you do that, though, is you can't have like 4,000 answered multiple choice questions that speak to the question of how to design bioweapons, for example, just floating around the internet, right? That is probably a bad idea. And so one of the things they've done is they've taken great pains to strip out stuff that they think is kind of dangerous to have floating around. That's a really, really difficult bar to hit or thing to slice up properly. They've hired, they say, consultants who know what they're doing, of course, to kind of figure out what's safe to have in this open source benchmark and what's not. But this is a fundamental limitation of any open source benchmark that evaluates weapon of mass destruction risk from open source or other models, right? If you're going to leak the benchmark out there, then you got to make sure the benchmark isn't compounding the risk itself. And so, anyway, it's as we've done a lot of our work on, obviously, policy and national security that we'll probably be talking about in a minute, this has surfaced often as a real issue. You want to have the open source community in a position to evaluate these potentially dangerous models, but at the same time, the evaluation procedures can often contain classified information, and you don't want that just floating around. So this is an attempt to kind of split the baby, if you will, and do the best that they could subject to that constraint. They focused a lot on questions that reveal capabilities that are slightly upstream from the specific dangerous capabilities they're worried about. So, for example, there's certain chemistry knowledge or say biology knowledge that you might need in order to make a virus. So they're going to check for that baseline knowledge as much as the knowledge required to design the virus itself. And they'll try to do it in a targeted way because, remember, they're going to then turn around and try to use this benchmark to train out these capabilities. And if they're too broad in terms of how they define the dangerous capabilities, they risk pulling out capabilities from their models that are actually desirable and useful. So that's sort of the frame up here. They then describe kind of this new approach that they're developing they call CUT, which is this, as they put it, state-of-the-art unlearning method based on controlling model representations. Really, if you've listened to the podcast, you might know this under the name activation engineering. So basically this idea that by controlling the activations of a model, the neuron activations in this model during the inference process, you can actually control the model's behavior. And in this case, they're going to try to do that to prevent the model from exhibiting certain dangerous capabilities. And they'll use it also as a training signal. It gets a little complex, so I'm not going to go into too much detail, but the bottom line is they use the model's performance on this WMDP benchmark and try to get it to perform poorly on that benchmark, to get those answers wrong while still preserving its knowledge across other desirable capability sets. So that's kind of what this is. They're doing something really interesting technically, and if you're interested in kind of the AI safety, especially the weaponization side, I do recommend checking out how specifically they're teeing up their loss function. They have like a special loss function that they call the forget loss that's trying to push their model to forget specific facts that they consider risky or dangerous. And it does seem to work in a pretty interesting way. So I just want to highlight that for anybody who's interested in this space. Check that out. It is a new paradigm and really interesting use of activation engineering, not to directly control the model, but rather to define a loss function that can be used to train out certain knowledge. So I thought that was really cool.
Yeah, really impressive paper. 22 organizations collaborating on this one with dozens of offers, and this released benchmark has these 4,157 multiple choice questions, just to, I guess, reemphasize, mostly focused on biosecurity, cybersecurity, and chemical security. Very ambitious effort for the safety side that I guess is very usable and useful in practice. So cool to see this coming pretty soon after we saw also OpenAI doing some similar evaluation of our models for their potential use in these kinds of areas. It's nice to see a very clear-cut way to actually assess danger and not be quite so speculative to me. Next up, we have a story. The US must move decisively to avert extinction level threat from AI, according to a government commissioned report. So this is a report that warns of substantial national security risk posed by AI, including a potential extinction level threat to the human species. The authors of the report interviewed over 200 government employees, experts, and workers on frontier AI companies. The title of it is An Action Plan to Increase the Safety and Security of Advanced AI. And I think, given that introduction, I can go ahead and hand it off to Jeremy to say more.
We always said we would never be the news, Andre. This has been my last week. This is the reason that I wasn't there for the last podcast. So this is the work that my company's been doing, or part of it, over the last year and a half or so, with the U.S. State Department and various other U.S. national security agencies and departments, trying to figure out, answering this question, like, what does it look like to take the trends we've seen so far in AI seriously. And if you do think that scaling works, or if you do think that we're close to breakthroughs that may lead, as OpenAI and many other labs have said, to human level AI sometime in the relatively near term, we need to have a strategy to take advantage of the benefits, the insane benefits of that technology, but mitigate the downside risks as well. And so this really was the first ever US government commissioned investigation of the risks, the potential risks of AGI level technology, among other things, risks from loss of control, and also risk from weaponization. And it involved talking to, over 200 folks from across the US government. We're talking here about the world's leading experts in weapon of mass destruction technology, chem, bio, rad, nuke, as well as cyber and other emerging tech, to try to find kind of precedents that we could map onto AI risk and sort of understand what lessons could we learn from that risk class. We also did speak to Frontier AI Labs. We spoke to the CEOs of a lot of these labs, and as well as other executives, and as well as researchers who, many of them spoke to us on condition of anonymity and had some concerns to share about what was going on security-wise and safety-wise in the industry, among other things. And all of that informed this action plan. It is the first ever action plan commissioned by the US government to address this risk class. And so we're really pleased to have done this. It did give us like a weird level of access to the internal workings of these labs, and also of the US national security apparatus that's trying to grapple with and kind of get its arms around this problem that really just came on everybody's radar like a year and a half ago or 2 years ago with ChatGPT. By the way, we started working on this. Like, this thing was commissioned a month before ChatGPT came out. So the only, we're very fortunate that we can talk about it in this way, because, had it been released later, it may not have been as easy to make public. And we're very fortunate that our government partners here were so willing to make this open, so the general public could be made aware of some of the things that we discovered, which do, I think, speak to meaningful risks that may be on the horizon on the shorter term than a lot of people may realize. So very fascinating. I mean, this is really kind of the most fulfilling and fascinating piece of work I've ever done career-wise. Revealed some stuff that was maybe less fortunate, but other things that were really inspiring. And a lot of the work that labs are doing, especially look at Anthropic, the amazing safety work they're doing. Like, we do not have the answers to the safety question to how to align these systems and prevent loss of control, but man, are some really bright minds trying really hard. So that was our thing. You can actually go to our website if you want. You can go to gladstone.ai/action-plan, and you can check out some more detail on the action plan. You can even request a copy. It's like 250 pages. So if you feel like you don't have enough stuff going on and you want to read 250 pages of that, please do, and you will actually get an email from yours truly with the action plan. So that's, I guess, the whole story, but or at least, sorry, that's part of the story. We've been, by the way, I'm in DC right now because we've been doing engagements on the Hill, meeting folks. And one of the things, Andre, that I learned from doing that was we have some crazy smart listeners of the podcast who are literally staff in some cases in congressional offices, and they're we're talking brilliant people who've worked at some of the top labs basically, who are staffing there, which incidentally was just inspiring to see. The US government gets to benefit from all that expertise. But we're very fortunate to have those listeners, and that's something that I wanted to tell you earlier that I didn't get the chance to. So there you go, kind of a cool story.
Yeah, that's super cool. Congratulations, Jeremy, on finishing what seems to be a major effort. A 247-page report is pretty impressive, I'm sure, and it includes a lot. So yeah, congrats, and we'll be excited to see whatever action plan part 2 you'll be working on next.
Yeah, you can actually, sorry, as a last thing, we may be putting together a kind of a discussion episode, yes. Me and my co-founder. So we might post it on Last Week in AI, so you can get the deeper scoop.
Yep. And moving on to the lightning round, where we are going to move through a couple more stories a bit more quickly. The first one is evaluating frontier models for dangerous capabilities, a paper coming from DeepMind, quite relevant to the data set, the benchmark we just covered. So they cover a new program of dangerous capabilities for Gemini 1.0 models, and they cover 4 areas: persuasion and deception, cybersecurity, self-proliferation, and self-reasoning. They do not find evidence of strong dangerous capabilities in the models they evaluated, but they do flag early warning signs. Really building up on, I guess, the efforts from OpenAI we already saw on having an evaluation method for other dangerous capabilities or indicators of dangerous capabilities in these models. Now it seems that DeepMind has developed their own methodology that's similar. They have even something pretty similar in terms of kind of a scorecard where they have an evaluation called Money Talks, which is persuade a human to forfeit $20 bonus to charity. They have self-proliferation early warning, which is make progress on difficult tasks that represent how an AI agent might autonomously proliferate, stuff like that. And they have a rating from 0 to 4 in terms of capabilities on these various things. So yeah, more and more kind of evaluation strategies on the capabilities that are dangerous in models.
Yeah, I mean, I love this paper. There were 2 things that they did that I thought were really important. One, they made a really strong point of evaluating these models, not just like zero shot or sort of used as standard LLMs, but as agents. So they deliberately went to the extent of wrapping them up in a framework to turn them into agents, and then seeing if those agents could, for example, pass self-replication tasks or persuasion tasks or other things. So I think that's especially important for the reason that we flagged this whole thesis around more and more of the compute that we're going to see go into these models is going to be used at inference time. We're going to see more and more agentization, right? And so I think you have to try to push the limits of the model, beyond what the base model can do. And this is a really important way to do that. The other thing that I really liked about this, we've talked about this, I think, at least one episode in the past, but one problem with a lot of benchmarks that are used for evaluation is they tend to be kind of binary, right? So the model either succeeds at the task or it fails. And one of the things that you can hide, one of the things that strategy obfuscates, is the partial progress that the model might make as it kind of gets on its way to succeeding at that benchmark. So if you don't look at the partial progress, you can be taken by surprise where all of a sudden, a model that couldn't even come close to performing a task at one scale, maybe you scale it up and then it blasts it, blows it out of the water. And so what they do here is they actually look at the number of expert interventions that are required to allow a model to pass, to succeed at a given dangerous capability evaluation. And they measure that based on the number of bits that the expert intervention requires. So basically the amount of information, in a sense, that the expert has to provide to the model in order to get it over that hurdle, to actually get it to display that dangerous capability. And that allows you to sort of see on a continuum, like, how close or far is the model really? Sure, it may not succeed, at implementing a machine learning paper, which would speak to self-replication risk, but does it get close, right? How close does it get? And so they actually have a breakdown of that continuum of capability in one of their figures, and that they go into in detail in the text. So I thought that was really useful. We saw at least one paper play with that earlier. But a last thing to highlight here is we're still in the early days of evaluation for these things. And so Google is not actually going to release their full sort of set of evals here. They're just releasing their initial framework. I suspect part of the reason for this too is like trying to figure out which evals are actually safe to release and which ones aren't, for reasons that we discussed earlier. But yeah, I thought this was a great paper and another solid step by Google DeepMind.
Next up, Chinese and Western scientists identify red lines on AI risks. So, a group of international experts met in Beijing last week, and they identified the so-called red lines on the development of AI, including the making of bioweapons and launching cyber attacks. Some of these experts are kind of known names that have been commenting on AI safety, including Geoffrey Hinton and Yoshua Bengio, as well as Stuart Russell and Andrew Yao. And they say that the systems should not be able to increase the ability of actors to design weapons of mass destruction and not be able to autonomously execute cyber attacks really relates quite strongly to these several papers we just discussed. In terms of these papers were evaluating how to see whether the models had capabilities of self-proliferation or helping with dangerous weapons. And this statement essentially said, these are the red lines on AI development. We should make efforts not to develop models capable of these things.
Yeah, and it's sort of an encouraging next step in a series of engagements that we've seen between the US and China. Those engagements span both track one, which is like sort of, you can think of it as formal nation to nation dialogues, and track two, which are more informal dialogues between, for example, like academics or often like retired officials and so on. This one actually followed the international dialogue on AI safety, which happened in Beijing. That was about 2 weeks ago, at least at time of recording. And it included officials from the Chinese government, which was taken, at least by the authors of the article here, as a signal of tacit official endorsement for the forum and its outcomes, because those outcomes, of course, would have been predetermined before. So that's an additional step. Joe Biden, obviously, and Xi Jinping met back in November. We talked about that at the time to talk about AI safety, start to establish a dialogue there. And then we also had a bunch of companies that went down to China. I think we noted at the time Cohere was there, OpenAI, I think Google DeepMind as well. So a lot of these leading labs went down there to talk about AI safety in closed door meetings with Chinese AI experts. So this is kind of like, the attempt to kind of bridge the gap, start that dialogue and get to an understanding on the nature of the risk and what we're going to do about it. So interesting. It's a strong statement. It does explicitly call out, as you said, this idea of, yes, WMDs, but also the idea that a model, might be able to copy or improve itself without explicit human approval and assistance. Right? That was considered to be a no-go zone, a red line. So that speaks to the risk of loss of control. So sort of interesting that that's becoming mainstream, not just in the West as we're talking about this more and more, but with China as well, as we try to navigate what is really a challenging international sort of circumstance where we do have China is an adversary of the United States, and so we got to find a way to find positive sum games to play here, and it seems like a good step in that direction.
And moving on, just a couple more stories in the lightning round, with the next one being that Google was fined $272 million by French government over AI use of news content. So this was a French competition watchdog, and it fined 250 euros, which was equivalent to 272 million, over the idea that they used copyright information for training their models. That's about it. I guess pretty dramatic to see impact or consequences of using copyright data starting to happen. Of course, we have a ton of lawsuits going on over use of copyright content, but now real substantial fines starting to happen as well. And I do wonder if it'll hit others like OpenAI as well.
Yeah, and precedent being set, right? This is actually walking the walk, and we'll see if these fines continue, and if they get bigger too. 250 million euros. It's a big chunk of change, no doubt, but not clear that it's actually I don't know how much of a deterrent in practice it would be, though. To the extent that this is just France, right? So this is just France's own competition watchdog, the Autorité de la Concurrence. So there are presumably other such organizations within the other governments that could, anyway, levy these sorts of fines. So we'll see. I'm trying to think, the cost for licensing like New York Times content, Reddit content, it was in the tens of millions of dollars per platform. So kind of comparable. It's interesting. We'll see if this is actually an effective deterrent. I'm really curious how this plays out.
And the last story for the section, Elvis Act signed into Tennessee law to protect musicians from AI deepfakes. So the Elvis Act, which is short for Ensuring Likeness, Voice, and Image Security Act, updates the state's protections of personal rights to include protections for artists' voices from AI misuse. And this appears to be a first of its kind legislation to protect musicians from having their voices cloned. This is coming at a time where this is becoming easier and easier, with companies like Splice and Soundflower already creating AI-generated variants of music. So pretty notable to see an actual act being signed into law that, at least in this state, would make it illegal, prohibit the use of AI to mimic an artist's voice, and could be criminally enforced as a Class A misdemeanor.
Yeah, it also interestingly kind of precedent setting as we start to think about, what does federal legislation on this topic look like, and AI more broadly. It's kind of, it's challenging, right? Because you've got a patchwork of legislation at the state level. We covered this before, but I think we've had hundreds of legislative proposals. A whole bunch are actually being passed now. And one of the things that I suspect we're going to end up seeing is there's going to have to be some sort of federal level legislation for general purpose models, at least. That's a category where, because we're all subject to the risks associated with those models, it's sort of difficult to argue for state level patchwork regulation at that level. But for these more specific things, why not? I mean, and Tennessee, of course, right? You got Nashville, so no wonder. They're so focused on this dimension, and hopefully it's an area of law that they know particularly well and are well placed to kind of lead the way on and set precedent on. So we'll see if other states follow suit. But this sort of thing it's a push in the direction opposite the kind of just open source everything direction. So we'll see if it actually takes, and what kind of pushback it gets.
And just a couple more stories in our next section, synthetic media and art. The first one is once again from 4for Media, who we've seen publish quite a lot of looks into the world we live in with AI. And this one by them is on AI-generated science, and goes into the kind of emerging trend of seeing more and more ChatGPT type generation being used when writing scientific papers. They highlight that you can search for a phrase "as of my last knowledge update" on Google Scholar, which is a search tool for scientific papers, and that would return 115 results. So that basically means that there are published examples of papers where at least some or a significant amount of the text was based on ChatGPT. Now, most of the papers are probably being published at so-called paper mills, so not like prestigious things. It's not like we are necessarily passing peer review, or major institutions are doing them. There's already been a lot of sham papers that are known, but nevertheless, I think it's an interesting look into ChatGPT starting to do a lot of the composition of at least a portion of scientific publications.
Yeah, just the fact that those artifacts even exist on the internet just says so much about, and I don't know what exactly it says, but it definitely says so much about sort of academic incentive structures and what is being incentivized. Like, as you said, these are not reputable publications that these things tend to go in. But for it to be that sloppy, that nobody ever did a search of like "as of my last knowledge update," which is one of the first things that would come to mind, or as a large language model, trained by OpenAI, I cannot blah blah blah, those sorts of things. We've seen obviously a lot of cases where those phrases can be used to detect or out very low effort chatbots on Twitter. Mm-hmm. And that's, we're seeing, like, it's just weird to see that in the academic literature as like a thing that, you putting some level of effort into this would be nice. But I'm fascinated by the fact that this is a thing. And I'm trying to think like what the incentive would be. Back in my time in academia, obviously you wanted your name on as many papers as possible, but like, surely someone just like looks up the paper and you're discovered to be a fraud. That, yeah, I don't know. Do you have any sense of like what the actual incentive is to do this?
It's pretty hard to say. I mean, the whole existence of paper mills and these like pay to publish journals in general is a pretty weird thing where there are incentives to publish and to have your name on published papers. So this really goes along with that, where there are already means to publish low effort or low quality research. And so I guess it's not surprising that if people are already doing that, they would also then use ChatGPT to make it faster to do. But not necessarily like a warning sign for science in general, I think, because, at the end of the day, the goal of if you want to succeed as a scientist is to have your stuff read by other people, to have an impact. Another indicator of how, at least at the periphery of what people are making, there is this phenomena of AI spam, so to speak.
Actually, as you're saying that, and totally agree on the sort of general purpose, like let me get my name on all the papers type thing. But I wonder as well, citation count matters a lot. I wonder if this is maybe a way of, in some cases, pumping up your own citation count, especially if you're in a field that, well, actually, I guess all fields would be kind of similar in that respect. But that's the only thing I can think of that where the risk reward would make any sense, because you stand a chance of not getting discovered if you put a bunch of fake names on the paper or something, and it just cites your work and maybe cites a bunch of other people's work as decoys.
That's
right?
True. It could be. It could be. Yeah, an interesting idea. But either way, funny examples. And there was one example of an actually reputable paper and article. And there was like, certainly here's a possible introduction for your topic in that one. And the authors of that paper did say they'll look into it. So I guess I wouldn't be surprised if people in prestigious universities are also using ChatGPT to help them write. That, makes sense. It's not a bad thing, right?
You'd expect them to edit the papers, though. I'm thinking about like all the time that, I'm sure you as well, all the time you spend poring over and editing and re-editing your paper before it goes live. It's just, it's hard to imagine you'd miss something like that. But
yeah. Next story, YouTube adds new AI-generated content labeling tool, and that's it. It allows creators to label their videos for if they contain AI-generated or synthetic content. It's just a checkbox that appears during the uploading and posting process, and creators are now required to disclose any altered or synthetic content. So that includes, could be deepfakes, altered footage of real events, and stuff like that. Apparently, you're not required to disclose beauty filters or special effects like background blur.
Oh, thank God.
Yeah, because clearly you don't want to let people know if you're using that. So, following up on them detailing their AI-generated content policy earlier, where they on YouTube do allow looser guidelines for most people to be able to use it, and now they do ask people to label it if you include deepfakes.
Yeah, and as they put it, the new feature depends or relies on an honor system for now, but obviously trying to figure out what the standards are actually going to be going forward. And this is, in many cases, this is how law ends up getting shaped, right? The companies start to do it, it becomes more of an industry standard, and then it gets enshrined. So we'll see if this becomes a trend, but kind of interesting, and maybe not too surprising the way that they've split the baby here. It's sort of interesting that it's not all edits, it's not all synthetic content, but synthetic content that appears realistic. And I bet you a lot of judges are going to have a field day, and lawyers trying to kind of define what, how do you determine what appears realistic. And we're going to have if that ends up becoming like a legal standard at some point, which I could easily imagine it becoming. So yeah, really interesting result.
And to round things out, just one fun story, which we've started doing to not end on serious topics. I picked out just one fun thing from this Substack, Why Try AI, that has a lot of fun examples of stuff you can do with AI and some really nice roundups of various developments. And so the post is 10 of my most popular AI image series, just rounding up a lot of the generations that this person has done. It includes things like, cats throughout the world, cyberpunk farm animals, 7 deadly beans, just fun examples of stuff you can do with Midjourney and other text-to-image tools. And I often find it fun to see the sorts of things people get up to with these. And it's a nice reminder that you can do really silly, really out there, really ridiculous and entertaining stuff that, you probably wouldn't see these images come into existence if not for AI. So a fun post, and as always, we'll have all the links in the description so you can go and click on it to go see those images. And with that, we are finished with another episode of Last Week in AI. Thank you for listening. As always, you can find all these stories and more at the text newsletter at lastweekin.ai. And as always, we would appreciate it if you share the podcast, if you give us a nice review on Apple Podcasts, or if you just get in touch to give us some of your thoughts. You can comment on YouTube, Substack, or email us. The emails are in the episode description. But more than anything, we care that you do keep tuning in, so please keep listening.